Hello everyone, welcome you all to this course. So in this video we will try to solve this question, which is example number 9. So let us first try to understand what are the given data available in this problem and what is it asking for, right? So for that we have to read the question properly and understand each word, each line perfectly, right? So let us first read and understand what is the question given to us. Okay, so here it is telling that consider a steady flow of air in an adiabatic passage. Okay, so there is a passage, so which is adiabatic, that means there is no interactions of heat, right? So and there is flow happening, that means it is not the case of your open system, closed system, right? So it is the case of your open system, that means some mass is taking entry to the system and some mass may also exit from the system, right? So this is a pure case of control volume and open system, right? So let us try to read further. So here next it is telling air enters the passage at 100 kilopascal and 500 Kelvin. Okay, so initial condition or at the inlet to the passage, it is given at pressure is given and temperature is given, and velocity is also given, that is 150 meter per second. Okay, and leaves the passage at this temperature, that is 510 Kelvin. Okay, so assuming air to be an ideal gas, okay, and neglect potential energy changes and no work transfer occurring, calculate the velocity of air at the exit. Okay, so these are the given data to us, and what is it asking for? We have to find out the velocity of air at the exit of this passage. Okay, so there is a simple passage we can say. So let me draw that passage over here. So for that let me minimize this question. Okay, so there is some passage like this. Okay, so any passage, we do not have idea how this passage is. Okay, so some inlet condition is there and some outlet condition is given to us. So at inlet we are given with this is P1, okay, and this is, we can say, T1, okay, and this is my V1, right, velocity, and leaves the passage, that means at outlet this is given to us as T2. Okay, so P1, T1 and T2 it is given to us, and it is saying that we can assume this is as an ideal gas, air is an ideal gas, so we can use the ideal gas equations over here, right? So we can neglect the potential energy changes and there is no work transfer also, so we have to calculate what is that, that is P2. Okay, so this is a steady flow, that means no properties are changing at the inlet or outlet with respect to time. That means whatever properties are inlet at inlet over here, that is P1, T1 and T2, V1, all these things are constant with respect to time. Okay, it is not varying with respect to time, right? It may vary with respect to position, but it is not varying with respect to time. So that is the meaning of steady flow, right? Okay, so steady flow energy equations we have already derived, so that I can write down over here. Okay, so that is H1. So if I'm taking inlet, at inlet this is state point 1 or inlet condition as 1 and this is 2, then I can write H1 plus B1 square by 2 plus GZ1, okay, and plus this is Q dot, and that will be equal to H2 plus B2 square by 2 plus GZ2 plus this is 1. Okay, so what we can neglect, this potential energy changes can be neglected. This is telling that this is adiabatic passage, that means there is no heat interactions, right? And we can neglect this work transfer, so there is, this can also be neglected, right? So now we are left with this equation, that is H1 plus V1 square by 2, and that will be equal to H2 plus V2 square by 2. So this is the final equation we can see. So now here we have to find out what, we have to find out the value of velocity are the outlet of the this passage, right? That means we have to find out this V2. So we have to find out this V2. Okay, and V1 is given. So by any means, if I can find out the value of H1 and this H2, then definitely I will be able to find out the value of what, that is V2. Okay, and let us understand how we can find out the value of this H1 and H2. And as this is saying us that this is an ideal gas, air is an ideal gas, then for an ideal gas I can write H1 as CpT1, right? Similarly I can write H2 as CpT2. Okay, and these Cp values for air we know. So what is that? So Cp for air is equal to 1.005 kilojoule per kg Kelvin. Okay, so I know the value of Cp and I know the value of T1. Similarly, I know the value of T2. So from here I will be able to find out the value of H1 and H2. So if I can find out the value of H1 and H2, then simply I will be putting all these values over here and I can find out the value of P2. So before putting all these values here, we have to understand one thing. So here I have written this Cp in terms of kilojoule per kg Kelvin, right? So if we will be calculating the value of H1, then whatever value I will be getting over here, that will be in terms of kilojoule per kg, isn't it? Similarly, H2 will also be in terms of kilojoule per kg. But if we'll be talking about this kinetic energy term, this will be only in terms of joule per kg, right? Because here there is no term which is related to kilo. Okay, so if we'll be talking about to what is the unit, so joule per kg is equivalent to what? So let us try to see that. So joule is Newton meter and there is kg, right? And Newton is equivalent to kg meter per second square, and there was meter and there was kg, right? And this kg can be cancelled and we will be left with what? Meter square per second square. That means this joule per kg is equivalent to meter square per second square. So that means here whatever unit I am getting, that is what? Joule per kg. Okay, and what is the unit of H1? So here we are getting the unit, that is kilojoule per kg. So either we have to convert this kilojoule per kg into joule per kg, or I have to convert this joule per kg into kilojoule per kg. Okay, for that let us convert what? Let us convert our joule per kg term, which is related to our velocity term, into kilojoule per kg. So if we be doing so, then I can write H1 plus V1 square by 2000, right? And this is 2000, right? So 1000 I multiplied with 2, so I got over here as 2000, right? And here H2, so this is equal to, right, this is equal to plus V2 square by 2000. Okay, so now everything is known to us. Simply I'll be putting all these values which is given to us in the given formula, and from here I will be able to calculate the value of V2, right? And V2 value will be getting nearly equal to, so let me check. So nearly equal to, will be getting 49 meter per second. So 49 point meter per second will be the correct answer for this question. So option B will be the correct answer. Hope it was understandable. Thank you.